Level 6 Data Analytics Formative Presentation SRN BP0315096. So I've only recently gathered the data required for this project and I've begun to clean it. So this presentation will not contain any graphs or analysed data, but it'll be a walkthrough on the data sets I have and how I'll be analysing them. Just one moment there. Okay, the analytical task. The data I'm analysing belongs to NHS data sets over a 5-year period from 2018 through to 2023. 2024 data will be referenced in one of the processes later on. The data sets these data sets have been chosen in this time frame as it contains the COVID-19 pandemic data set, which we place right in the centre of the information. I thought this would be interesting data to understand predictions and machine predictions for analysis. I would expect the emissions to drastically drop in the 2020 and 2021 data set. However, I'm not sure if it differs regarding age and gender and the times of emission in regards to the rest of the data sets. I'll analyse the A&E admissions, looking if they changed after the pandemic year when the COVID-19 vaccine was administered, or as a society did we return to previous trends. The data questions that I have are, over a 5-year period, what was the volume of visits to A&E across England? What was the busiest time in A&E for admissions, focusing on time of day? And is there a consistent pattern, or has this changed over the chosen time frame? Who's attending A&E regarding age group and gender? Where are the patients going once they've been seen by A&E? Are they discharged, or do they just move to a different A&E department? And if so, is there a pattern, or is it sporadic? The data set that I'm using is hospital episode statistics, referred to as HES data. It's NHS England historical data over a 5-year period, and the data from the devolved nations, Northern Ireland, Scotland and Wales will not be included. It is England's data only that we'll use for this project. So the advanced statistics that will be used. So I'll use the following statistical methods to analyse the data. I will explain on the following slides why they were chosen. Linear regression analysis, time series analysis, cluster analysis. I've looked at logistic regression, but I think this may be a wrong choice. However, I'm going to put a slide in explaining what I'm trying to do with it, and we can raise it later in class or in a one-to-one, because I think it's the wrong one. Okay. Linear regression. So I'm going to use linear regression to look at the number of admissions into A&E over the 5-year period. I'll use the Python code that's produced that was provided in the course to show this. The purpose of using linear regression for this part of the project is it can show a value of unknown data based on historical data that we're going to put in there. Because of this, I intend to run 3 tests, and out of those 3 tests, I'm going to produce 4 graphs. Test 1 will be pre-2020 data, so the prediction should not show the COVID-19 impact. So in theory, the graph should continue when it's gone from being known data to predicted data to look very similar, just showing ongoing trends. Test 2 will include COVID-19 data, so the model will show an outlier, as it will suddenly drop. And it should show predictions based on the relevant 3 years. So it will start showing as if the numbers to A&E are decreasing and potentially will continue to decrease. The reason the A&E admission should drop at that point, even though it was a pandemic, is because the country went to national lockdown. And because of this, in theory, there was less accidents as there was less people on the road, bars and clubs were shut, maybe less germs being spread as we were all staying, I think, within 2 meters away from each other. So all these potential reasons why people were not attending A&E when they normally would have done, although there would have been admissions for various other things, but it should have dropped dramatically. Let's have a look here. So test 3 will include all 5 years of the data. So it will have all the data we've got, 2018 through to 2023, and it'll give us a prediction for 2024, what it thinks it'll be. So now we'll have 2 years after COVID, where everything seemed to potentially have gone back to normal. What I will do then is I'll create a fourth graph, and on that fourth graph I'll use the actual data from 2024 to see how close the model was to what the predictions were. From a business case point of view, this data could potentially be used to look at the predicted volume of A&E admissions and might contribute to either extra or reduced staffing if necessary. Costings regarding staffing, both medical and administration, and a potential need for extra building space or possibly more advanced technology or digital storage at admission desks if the admissions are rising. These are some of the things that we use as NHS business cases. They might not use this, but it could be used for that. I'll produce these graphs and put them on here, as I said, the 4 of them. Date will be used for this graph. Date will be used as the independent variable because the year hasn't changed. Later on, when I'm looking at time frames, that'll be different. So, well, this one I'm going to look at now. So the next one I'll look at is time series. So time series will be used to look at the times that A&E had the highest volumes of admissions. So I'll break these data points into 4-hour time frames starting at midnight. Looking at the data over the 5 years, with 2020 being the centre, it'd be interesting to know, where did the peak times change? Was there ever a pattern in peak times, and did they actually change? What were the peak times before the 2020 pandemic, and was there a trend that continued after 2020? And can prediction be made via forecasting? The reason I think this would be interesting is before 2020, potentially, and I'm not sure if I got it correct, so just check the data, but I think potentially Monday mornings, early Monday mornings were the highest A&E, people attending A&E. I'm not sure if it's linked, but people now, the majority of office workers are now work from home, so it'd be interesting if that data is still high on a Monday morning. Is it still that's still problem still there, or has it changed, or was it just not linked? From a business point of view, this type of data could be used to address staffing rotas. I'll probably use Tableau to do this graph, or I can use Power BI. I'll start off in Excel anyway, so I'll put them on to doing that. Clusters. So clusters are a collection of data based on similarities, and they'll be clustered together in a graph. So the HES data shows ages for who's been taken into A&E, but I need to format this into 5-year clusters as it's the data set we have is a little bit sporadic. So I'll put it into 5-year clusters to avoid skewing the data. I'm going to have to cross-reference with the Office of National Statistics data as well regarding the population's age group at certain times. I think potentially the data will show a small number of people aged 80 plus. So people over the age of 80, I think it will show a small number of patients who are at that age group that were admitted, and it would skew the data to imply that the age group do not attend A&E as often as everybody else because their percentages on the overall chart is potentially lower. But if I reference against Office of National Statistics data, it might show that a lower percentage of the population is over 80. So it means it's not a lower number of 80-year-olds are attending. There's just not many 80-year-olds plus about compared to everybody else. Clusters will show what risk groups are attending A&E and is it a trend. From a business point of view, this data could be used to address types of care that might be needed, depending on who's coming into A&E. If it's showing high as infants or the elderly, potentially hospitals might need different types of treatment or professionals or equipment, potentially. So on to the next one. And with that, I'll do the clusters looking at the different age groups and who's attending, but I'll have to base it, as I said, off the Office of National Statistics to make sure it's a fair reading as to how many people are actually in the country having age between 30 and 35, etc. So this one that I've put on, I wanted to do, I put logistical regression, but I'm thinking that might be the wrong thing to do because it's not a straightforward categorical prediction on here. So logistical regression is used for categorical predictions. So this is potentially the wrong choice. So in theory, this is what I want to analyse. I want to look at who is being transferred to a different ward within NHS and who's being discharged. So if people are just coming in and they're getting seated and they're leaving, that's fine. But if people are going into different departments, I want to know which department they're going to. I don't think logistical regression can predict that and what's coming in, so I need to check that in class. I can break down the admissions via age group into clusters, and I can break that cluster down to what department they were sent to overall. But I don't think we'll be able to predict if the patient was going to be kept in. So I'll need to check in on that. But from a business point of view, if I was able to analyse which departments patients were potentially moved into beforehand, it'd be helpful regarding staffing, finance, and estates data. So that's the work I have for now, and I will work on the graphs for the final submission.